We're now starting to move from concepts into mathematical formulas. So with every gas law that we'll be exploring, there's a mathematical formula. And today we're just going to look at the variables volume and pressure. So remember, we have volume, pressure, temperature, and number of moles. If we're talking about volume and pressure, we're going to keep the number of moles constant. So the first thing I'm going to do is put some moles of gas into my container. And then I'm going to put on this, and you can see right away, even though as soon as all the collisions start going equally, we'll have 5.8 atmospheres of pressure. Okay, and I can change that from atmospheres to kilopascals. I'll just leave it in atmospheres right now. I'm going to do this collision counter. Okay, so my collision counter here, I have to hit go, and it is going to sample 10 picoseconds. How many collisions happen in 10 picoseconds? Which, of course, this is slowed down so you can see these particles moving, but they're actually moving quite rapidly. So now we have a constant number of moles in there. My temperature is 300 K, and we're going to keep that constant too. So now all we're looking at is pressure and volume. And here I have a volume inside this container, and I can make that smaller. So right now my pressure is 5.8 atmospheres. What happens when I make that container smaller? Remember, when I say pressure, you need to think number of collisions. Pressure equals collisions. So let's see, will I have more or less collisions? So now I've made it smaller, and we can see my pressures increased. Now, why would that happen? So here's my collisions, and I need to reset it for my new volume. I had 39 collisions per 10 picoseconds in my larger container. Now that it's smaller, I have 44. So my collisions have gone up. Well, my particles have less distance to move to hit the side of the wall. So this is why I have more collisions when I have a small volume. If I have more collisions, I have more pressure. So smaller volume, let's get rid of that counter. Smaller volume, higher pressure. Larger volume, my pressure went down. Smaller volume, decreasing the volume, pressure went up. Let's decrease it some more. Pressure went up. So as my volume decreases, my pressure goes up because I get more collisions against the wall. I have the same number of particles, but they have less distance to travel, which means they can hit the walls more frequently, more collisions.
So we're going to be exploring Boyle's law, and Boyle's law looks at pressure and volume. And so we're going to keep our other two variables constant, which is temperature and number of moles. This right here is an enclosed syringe, so there's only so many particles of gas in there, and the number of moles is not going to change. And the temperature is going to be kept constant. It's helpful to visualize what's happening with these particles inside the syringe as I'm changing my volume. So here's my pressure gauge right up here, and it is being measured in PSI, okay? And right now I have 15 PSI of pressure. So if I take this syringe and I make it smaller, you can see my pressure's increasing. And as you just saw, that's because my particles have less distance to move to hit the other side of the wall. So if they have less distance, they can have more collisions, which increases that pressure. Okay, so what we're going to do in this lab is we're just going to explore this, and we're going to make a graph. Right here, I'm getting some data. I'm going to clear the data, and we are going to get our data for our lab right now. Okay, so we're going to start with a volume of 7 and a pressure of 73.5. Okay, and I'm just going to keep getting some data here. You can see as the volume increases, my pressure is decreasing. So now that we have this data, you're going to fill this out in your data table in your lab worksheet, and you are going to graph this. So you may want to graph this on a piece of paper and upload your graph if you're doing this virtually, but you need to have a graph. And remember, our graphing rules are all laid out in the worksheet. You need a correct title. You need your X and Y axis labeled, and both labels have to have the correct units. Our X and Y axis has to be in even increments, okay? My increments can't be 7, 9, 12, 14, 17. You have to start at 0, and then you can go by 2s, 4s, 5s, whatever you need to, but your graph has to cover 3/4 of the entire graph, okay? You can't squeeze it down all the way at the bottom. You have to spread out that data. If you don't, you can't see trends. So you'll be graded on that proper graphing, and if you need help, talk to me about that.